All right, we're going to be balancing a redox reaction again, but this time we're going to be performing that redox balancing in a basic solution. And there's just a little bit of an additional step down here for balancing in basic solutions. You're going to find that the majority of this process is exactly as what you've done for every other balancing redox reaction. So our first step is to divide into half reactions. So I'm going to go ahead and do that. I've got my ASO3 3 minus. Yields my ASO4 3 minus, and then my other reaction is my I2 yields I minus. All right, so my first step after that is to balance each half reaction by balancing elements that are not O or H. 1AS, the top reaction is fine, but the bottom reaction is not. It's got 2 I's on the left and 2 on the right. So we're going to go, or 1 on the right, excuse me. So we're going to go ahead and put a 2 in front there so that that is balanced. So next step. Balance our oxygens by adding H2O. So in my top reaction, I have 3 oxygens on the left and I have 4 oxygens on the right. So I need to add an additional oxygen on the left-hand side by adding water. Bottom reaction, no oxygen, so we're fine. Next step, balance hydrogens by adding H+. In my top reaction, I have 2 hydrogens on the left and I don't have any hydrogens on the right. So I'm going to go ahead and add 2 hydrogens, excuse me, on the right-hand side to balance the H's. Again, bottom reaction does not matter at all. Finally, balance charges by adding electrons. Again, I think this is a lot of times the trickiest step. So let's go ahead and figure out our charges. On the left-hand side here, my charge is -3. On the right-hand side over here, let's add that all together. I have a -3 plus 2 positive charges. So my overall charge here is -1. In order to equalize these, I have to add electrons to the side with the highest charge. So that's the -1 side. To make it equal to the left side, I need 2 more electrons because I need 2 more negative charges. Bottom reaction, I've got a charge of 0 over here and -2 over here. And so in order for us to equalize that, again, we add electrons always to the side that has the greater charge. I'm going to add 2 electrons over here. All right, so now that I've done that, we've balanced our charges by adding electrons, we're going to multiply to equalize electrons. Now, I gave kind of an easy example here. If you notice, my electrons are already equalized, so I don't have to do any multiplication there. I'm just going to simplify and add our half reactions together. All right, so we're going to add our half reactions together just like we've done. If you notice, this is no different than what we've done for every other example so far. My electrons are going to cancel out, and I really don't have any other cancellation that's going to happen. So I go ahead and write this out as H2O plus ASO3, 3 minus, plus my I2 yields 2I minus plus ASO4, 3 minus, plus 2H plus. All right, so that's what I start with. But now because I am in a basic solution, this is the one extra step. So let's go ahead and look at the rules. For basic solutions, it says to eliminate H plus by adding OH minus to each side. Okay, so we need to go ahead and eliminate H plus by adding OH minus to each side. All right, so let's look to see where we have our H pluses. I have 2 H pluses here, so I need to add 2 OH minuses, and I do have to add them to both sides. So whatever I add to the side to eliminate the H pluses, I have to add the same to the opposite side. Once I've done that, if you notice, H plus and OH minuses form the compound water. So we're going to be creating water to, and we're going to add it to or cancel from the equation. So let's see what we're going to have here. This is going to become 2 H2Os. And now let's take a look at canceling. You see that I have a water on the left side, and now I have 2 waters on the right. And so what that's going to do as far as cancellation is going to be concerned is the water on the left is going to go away, and we're going to be left with 1 water on the right. So my overall reaction is going to be 2 OH minus plus ASO3, 3 minus, plus I2 yields 2 I minus plus ASO4, 3 minus, plus H2O. Again, you see that the majority of this problem is exactly like what we've been doing. We simply add this at the very end once we have our balanced reaction and simplify our waters.